said pie chart at the end of the last one, but we will get to the pie chart in just a second. But before we do that, we're going to read a side-by-side bar graph. So the striped bars are the year 2009, and the solid bars are the year 1990. So it's asking us the percentage of respondents in 1990 who have a bachelor's degree. So we just go up to bachelor's degree, which is right here, and 1990 is the solid, so that would be here. Now, it's not exact because I don't have grid lines. It looks to me like it's a little over half. Half would be 12.5, so I'm going to call it 13%. So it would be 0.13, which is 13%. If there were 240 million people in 2009, how many of them had a high school diploma? I go up to high school diploma in 2009, that's here, and that's past 30, but it looks to me like it's about 31%. So I'm going to do 240 times 0.31 for 31, and that gives me 74.4, and it's in millions, so 74.4 million. Because 31% of 240 now needs to multiply. All right, so 186 million in 1990. How many had an associate's degree? So I go up to 1990, associate's degree. Looks to me like 6%. So 6% of 186 million, that's going to be 186 times 0.06 for 6%, and you get 11.16 million. All right, so then flipping over to our pie chart. The first thing you have to do when you're constructing a pie chart, remember that pie charts are divided into sections based on the percentage of the circle that they take up, which means I need percentage, which is relative frequency. So in order to get that, I have to have the total, the sum of all the frequencies. So the first thing I need to do is to sum these. So you just punch those into the calculator and get the sum. 4,776. And then because it is a pie graph and I'm going to need percentages anyway, I'm going to go ahead and write my relative frequencies as decimals, not necessarily as fractions. Besides, these are ugly, big, nasty fractions. So I'm just going to write the decimal. And I'm using 3 decimal places for right now. Unless it specifies 3 is probably plenty. On MyLabs Plus, they're usually very good about telling you what decimal you need to round to. Okay, so now if you were going to build this pie chart, now thankfully we don't really have to do this much anymore because we just let our computer do it. But if you were doing it, what you would do is take a circle is 360 degrees. This is a percentage, so I would do 360 times 0.527 to figure out what degree angle that I need for my for that particular piece of the pie. So in this case, 360 times 0.527 comes out to be 189.72. So a little bit over 180. So straight across would be 180. If I drew straight across, I'm going to draw a little bit down from that and say this is my always section, which is 52.7%. Now the next one is 26.3%. So I multiply that by 360 and I get 94.68. So I'm going to flip this around, use this as the side. 90 would be straight up. So 94 is just going to be just slightly. So I'm not going to be exact here, but it would be straight up if it was 90. So I'm going just slightly less than straight up, or more than straight up. So this section is my most of the time section. And it's 26.3%. My next one, 11.6%. That's a 41 degree angle. So again, I'm going to use that 45 would be right here. So 41, a little less than that. That's going to be my sometimes section. And then $24.48. That will be my rarely section. All right, what percent of respondents answered always? Well, always is 52.7%. what percentage of respondents answered never or rarely? Quick reminder, or. Or means add. So never or rarely, so I'm going to add the 2, 0.068 plus 0.026, and I get 0.094, so 9.4%. Suppose that a representative from the CDC said 52.7% of all college students always wear a seatbelt. Is this descriptive or inferential? All right, well, the 52.7, that comes straight from our study. Always comes straight for our study. But right here it says of all college students. And our study was Weatherford College students. So as soon as we took this study and we applied it to all college students, it became inferential. Because we're applying a study of a sample to a whole population. So we're inferring that because that's the case at Weatherford College, that's the case at all colleges. So it became inferential statistics. All right, that is all for that section.